Howdy folks. So this video is kind of jumping into the middle of a project because it's such a big and complicated thing that I haven't really bothered to film every aspect of it just because it's kind of difficult. So I thought I would just sort of jump in the middle and sort of explain what's going on before it's finished. And I think I'll maybe make another video or just tack it onto this video when it's actually done. So I made a video very recently about moving my my file server Tesla from this case into a new Corsair Obsidian 750D case. And the reason for that, I sort of alluded to that in the beginning of the video, was because I'm building another file server, which I have named Darwin, and it is this machine right here, which is already built. I didn't film the actual construction of this just because it was kind of boring. I mean, assembling a computer is not something terribly interesting. So let me explain what's going on here. So Tesla is a 24 terabyte file server, uses ZFS. It's got a bunch of SSDs and other stuff in it. It's a pretty decent file server. And one of the things that I've always wanted is to have proper backups. And when you have 24 terabytes of array space, of which 20 terabytes is actually occupied by data, it's, you know, you need 20 terabytes of preferably redundant storage, and it's difficult to get that, at least with all the media that I had. I have a bunch of old, 1 terabyte drives left over from an old server I dismantled a long time ago, all that kind of stuff. But if you add up all the available media that I have, it's not enough. So I actually don't have a one-to-one backup. I can back up pretty much everything that's important. The data that's not backed up is not critical data. It's the stuff I can get again, or download from cloud service providers, that kind of stuff. But I'd like to have a very easy backup system. And of course the old one was all manual. It's basically plug a drive in, copy as much data as will fit on that drive, write down what's on the drive, then get the next disk. It's very annoying. And of course, if any of those disks fail, because of course they're cold storage, if any of those fail, then you're screwed. And keeping it up to date is difficult because how do you know what files have changed, what files haven't? So you kind of have to just copy everything again, and it takes forever. It's really just not a good way to back up stuff. So I've always wanted to just have a dedicated machine that does nothing but backups, and that's what I've done. So Darwin has 8 4 terabyte disks, just as Tesla does. They have exactly the same storage array configuration. And this will basically allow me to use ZFS's send-receive functionality. And if you haven't heard of send-receive before, it basically creates a bit stream. ZFS send creates a bit stream of a data set, and you can pipe that with just a regular Linux or Unix pipe, send that wherever you want, and ZFS receive will receive a bit stream. So you can do whatever you want in the middle there. So in the normal situation, you would use SSH, for example, to pipe a bit stream from one machine to another, and you could copy the data set from one machine to another. And the great thing about ZFS send receive is that you can do it on incremental snapshots. So you can create 2 snapshots, send one snapshot, and then when you create the next snapshot, ZFS send will only send the incremental difference between the two, which is generally not that large. So you can do very efficient backups over a network. And that's what I wanted to do, basically have it completely automated. So the way that I envision this working is Darwin will be off all the time. It'll just be completely powered off. And there'll be a script that runs as a cron job on Tesla, the script that I'll write. I've written some of it. It's not totally done yet, but it's not a very big thing. It will basically run that task at like 4 in the morning or sometime when I'm not doing anything. And it will basically send a wake on LAN magic packet to Darwin, which will cause the network card to boot it up. And the script will sort of just wait a little bit and then poll it to see when it's finally up. When it's up, it'll log in over SSH onto this machine, and then it will then do a send receive. It will initiate a send, and then it will use the login that it's created over SSH to start a receive. Or you can actually do this all in one command, actually. and it will then do a send receive. Once that's done, it'll just power off Darwin, and it'll do this once a day, once every 2 days, whatever schedule I decide. And that way, you will always have, you know, the latest 24-hour changes, basically, which is the best that best that I could possibly hope for. You know, in case there's a catastrophic problem that destroys all the data on that machine, which does happen. I mean, RAID is not a backup. Please understand that RAID is not a backup. Even ZFS, ButterFS, they're not backups because, you know, yeah, you can have N+1, N+2 redundancy, all that kind of stuff. In this case, N+2 with RAID Z2, but, you know, what's to say the power supply doesn't blow up and kill all the disks, or there's a fire, or one of the SATA controllers decides to shit the bed and corrupt all the data. I've seen these things happen. So you need a completely separate, isolated machine, and that's why I've chosen Darwin. So Darwin is made mostly of parts that I already owned. So it's the case I already owned. The motherboard, CPU, and RAM are from that rig that I used to call Trash Panda. It's basically just a bunch of stuff that I found in e-waste. I fixed the motherboard. That was another video, and it's working properly now. So I've just added a couple host bus adapters to it, and it supports 9 disks. So 8 of the disks I went out and bought. Actually, no, I should say I bought 7 disks. And the 8th disk is actually a used 4 terabyte disk that I already had. It was a disk that was in Tesla, and ZFS said it was a bit flaky, so I took it out and put a new one in Tesla, but I kept the disk, and I zeroed it and all that stuff, and it seemed to be okay. So I put it back in the backup server, and if it fails again in the backup server, then I'll just get another disk. But if I can save myself $180 or whatever, they were actually on sale for $160, but whatever. If I can save myself, you know, some money by doing that, I'll do that. And the boot disk is just I can't believe I did this, but I took an 80 gigabyte, 10-year-old disk. It has a crazy, ridiculous power on hours count, but it's still, you know, technically perfect bill of health. So that's the boot disk. The boot disk doesn't matter. I mean, because it's a backup server, nothing really depends on this. The boot disk can completely crap out, and I don't care. And what I'll do is I'll take a disk image with probably like CloneZilla or something of that disk. So that way, if the disk does crap out, I can just grab another 80 gig disk, because I have a bunch of them, and just image it, put it back in, and the backup server's up and running. The OS will change so infrequently on this machine that I'm okay with doing that. So I don't need to buy an SSD or anything like that for that machine. I'm trying to keep the cost low. The power supply is another scrap find. Cleaned it up. Seems to be perfectly fine. Yeah, so that's the point of this. So what is going on right now? This is obviously under my desk, and it's not where it normally would be. The reason why is because I need to take all the data that's on Tesla and put it on this initially, which is, like I said, 18 terabytes of data. So I don't want to do that over gigabit Ethernet. I want to use my 20 gig InfiniBand to do that. So I took the host card adapter out of Volto. It's my workstation, and I put it in this machine. It's borrowing it temporarily to just get the data over quickly. And because of the length of the cable, I just brought this machine over. It was easier than trying to get the super thick copper InfiniBand cable to reach somewhere else. So I just shoved it under here. I can't use my workstation anyway, so it's fine where it is. I just got a keyboard and a monitor here, and you can see I'm doing a transfer, and you'll notice that I'm not using SSH to actually do this. There's actually a script that I've created, and the monitor's going to go to sleep now. So I've created a script which moves all of my data sets one after the other, so it's all unattended. And I'm using an application called MBuffer to actually do the moving. And the reason why is because SSH is actually really terrible when it comes to speed for like large amounts of data over a network. Because what you're going to get is you're going to get basically the I/O is going to be CPU bound basically, because SSH is an encrypted protocol, so it's going to encrypt all of the data and that's a slow process. So if your array is capable of like 600 megabytes a second or something, your CPU is not going to be capable of encrypting 600 megabytes a second. In this case, the slow machine is actually Tesla, because it's got a Pentium in it, and it can do about 70 megabytes a second, absolute maximum. So yeah, I'm not going to be using SSH for this. It's easy because you can just do one command from one machine and it auto logs into the other machine, and it's really easy. And I'll probably still use that for my incremental backups, but because this is a local network, there's no security risk of not encrypting the data. I'm using basically MBuffer, and MBuffer is very simple. You basically just pipe data into it on one end, tell it to send it to another host, and then you run MBuffer on the other host, telling it it's going to receive data on a certain port, and it just pipes it out. And you can specify the size of the buffers that it transmits, and I've chosen 128 kilobytes because that's equal to the ZFS block size, so you get a really nice efficient transfer. And yeah, I just create a gigabyte buffer on both sides, and it just copies things much faster. And there's really no CPU overhead with this, unlike SSH. So it's really nice. And sometimes you'll see it. It'll be 500 megasecond, 600 megs a second, and sometimes it'll drop down all the way to like 60 megs a second, or like 10. And the reason why it does that is because there is stuff wrong with Tesla. There's stuff wrong with there's nothing physically wrong, no hardware problems. It's exclusively something to do with ZFS, the way that the pool was built. I get the feeling it's probably to do with upgrades over the years. I originally built that pool with ZFS version 3, and it's been upgraded to version 5. And there's actually a bug in ZFS that if you do the upgrade from 3 to 5 directly, what will happen is I think it has to do with pools that are upgraded, and you enable shared attributes. If you do that, what will happen is if you try to read data, then modify it and write it back, ZFS will do the upgrade of the data at that moment. It doesn't upgrade everything when you upgrade the pool. That happens instantly. It just basically makes all the changes from then on different. And it basically, there's something wrong with the code that does the conversion, and it causes ZFS to kernel panic. I did a video on probably my second channel where this happened. It crashed the server, and then I couldn't bring the server back up, and I thought something was horribly wrong, and it was like 4 a.m. or something, and I was flipping my shit. So I think there's a video on my second channel a long time ago about that. But it's a problem that's happened before, and it basically, under normal load, it doesn't happen, but only under high load, this bug sort of shows its face. And that basically means if I try to run big batch tasks, like if I script a bunch of stuff, usually it'll crash. So I can't script stuff, which is a big problem. So my hope, basically what this backup server allows me to do is it allows me to copy all the data from my running copy of data to a full backup that's proper and redundant, and then I can destroy the pool on Tesla, tear it down, completely rebuild a new pool from scratch, and then copy the data back. And by doing that, I should basically alleviate this problem. And because all the data will be created using ZFS version 5 natively, and all the shared attributes will be enabled by default, therefore there won't be any problems. Now, now I do have one question that I'm not sure of the answer to, and I'd actually have to almost look at ZFS. Even the documentation isn't really clear about this, and it has to do with how send receive works. Send receive basically, according to the OpenZFS documentation, it sends basically instructions to the other machine as to how to generate the same data changes with as minimal data transfer as possible. And what I'm not sure of is when I do the send receive from this machine to this machine, I don't know if that ZFS version 3 attributes and stuff are copied, or if just the data is copied and then the attributes are put on by this machine. I don't know, because if ZFS send gets rid of all of the version 3 stuff and all that stuff, then I can just basically do another send receive back. But if it doesn't, then what I'm going to have to do is do an rsync. I'm going to have to basically ignore ZFS and use an rsync to bring it back, and then I'm going to have to destroy this and then do another send receive this way. So I'm not sure, so I'm just going to copy it this way, then copy it back. I'll probably just do a send receive. I'll copy it back and see if the performance gets a lot better, and if all the other sort of weird stuff besides that issue seem to have disappeared. And if they have, then I'll just leave it at that. But maybe I'll have to do an rsync in the future. I'm not sure. But yeah, that's what's going on. It's taking a long time, because sometimes, I mean, sometimes it drops almost to the kilobyte. It was just actually in the kilobytes per second. Sometimes it has to do with what data, what types of data, size of each file, all that kind of stuff determines how quickly I can replicate the data. But generally speaking, the HDD activity light on Tesla is solidly lit and has been since 10 p.m. last night, and it's it's not the current time. It's 5:30, 6 o'clock the next day, and it's still going. And the other thing you'll notice is that the HD activity light on Darwin is not solidly lit. So this sort of gives me hope that it's not copying all the attributes and stuff that are ZFS version 3 and all that kind of stuff, because obviously it's bound by the sender, not the receiver. This will also clear up some fragmentation. My pool isn't terribly fragmented. It's only about 16% fragmented, which is pretty good for something that's 20 terabytes. So, yeah. Anyway, that's the plan. Anyway, that's what I'm doing. And unfortunately, this is probably going to still take another 6 or 7 hours. It's probably going to be about 25 hours in total to go one way. And then my hope is that when I tear this down, I can go the other direction in under 10 hours. That's the theory. That's how I'll sort of judge if ZFS send receive has sort of fixed my issues, is how fast the send receive in the other direction is. If it's the same length, then it hasn't done anything. But if it's faster, which I expect it to be, then I'll be pretty happy. So yeah, anyway, let me show you actually what's inside this machine. It's quite ugly, but yeah, I'm going to need a flashlight because it's under my desk. But yeah, it's just a kind of cheap Sparkle Power CPU or power supply. I'm not particularly happy about that, but anyway, it's not modular, so it looks like shit. And I've got so many Molex to SATA adapters in this thing because it's only got 2 SATA normally, and I've had to put 9 SATA in this. So all the discs, all of the 4 terabyte discs are in the normal 3.5-inch bays, and then at the top there is I've just got some adapters that make it. That's the boot disc, the 80 gig boot disc that fits in a 5.25-inch bay. It's got 8 gigs of memory in it right now, but 2 of those are actually from another machine. 2 of those sticks, which is 4 gigs, are from another machine, so I may have to pillage those and bring it down to 4 gigs, but I don't really care because, I mean, it doesn't need more than 4 gigs because of how little it's actually going to do. It's not going to be a file server. It's just going to be receiving a snapshot, writing it to disk, and then powering off. There's no level 2 active replacement cache. There's no external ZFS intent log. There's none of that stuff in this machine because it doesn't need them. Performance is not a big deal. So it's a AMD quad-core AMD Phenom 2 X4965 at 3.4 gigahertz, which is a bit overkill, but I mean it's what I had. So it's got 2 HBAs in here right now, plus the InfiniBand card, and I've also got a PCI Intel Gigabit card, which I'm okay with using the PCI card because I kind of just want to get rid of it. And network speed's not a big deal because it's going to be, like I said, doing incremental snapshots, which are not that big, and it's going to be doing them in the middle of the night, so I don't really care how long it takes. The two HBAs, one of them is going to be in this machine permanently, the green one on top that I bought specifically for this. The black one's actually out of Tesla. I think I mentioned this in another video, but I have a 4-port HBA that's that's actually in Tesla, and it does it's connected via PCI Express X1, which is bottlenecked basically because of that 5 gigabit link. So I only use 2 ports of it, and I've got this other HBA which is currently in here, and that one I use to sort of split the load up 2 and 2, so that avoids the bottleneck, because these discs can't saturate SATA 3. But I've ordered another HBA for this machine, but it hasn't come in yet, so I've sort of pillaged that one out of Tesla for the moment, and that one will eventually end up going back in Tesla, and I'll have a new one, which I've ordered from China. It's one of those generic, cheap, like $6 ones. It's got the exact same as media controller as the one I bought, so I mean, it should be exactly the same. But I'm going to put it in the backup server, because if it decides to shit the bed, it's just the backup server. I mean, when I can go to the computer store and buy basically the exact same card, looks exactly the same, and it costs me costs me at least 4 times as much, plus recycle fee and tax and all that stuff. So yeah, if it turns out to be like a decent card, then I mean, that's where I'm going to be getting my cheap 2-port HBAs from now on. So yeah, when everything went okay, I mean, all the discs were, none of them were DOA, they were all perfectly healthy, they're all still perfectly healthy. One of the discs had a bunch of, it actually stopped responding several times, and I eventually came to realize it's actually a bad SATA cable I had, which is odd. I've never actually had one of those before, and it may have been the free SATA cable that came with the HBA I bought, so go figure. But yeah, I'm now pretty much out of Molex to SATA adapters, and I'm out of SATA cables because of this machine. So I'm going to have to go shopping for those next project. But anyway, at this point I'm just rambling on. I don't really have anything else to talk about. But when this is done, I'm going to post a video about all the scripts that I've created for this, how I'm actually doing the actual backups themselves. What else will I talk about? I'll talk about the pool geometry and a couple of other things that I've done, but I'll do that once it's all done and working properly, and I can actually talk about that. But yeah, that's what I'm working on. So if you're wondering why there's no other kinds of videos, it's because I can't even use my workstation right now because of this. So this is kind of taking my entire life, and it's probably gonna bleed into next week. So anyway, yeah, I'm just waffling at this point. So anyway, that's an update from me, a project update anyway. So hopefully that was interesting. Thanks for watching.